Yeah, good question. Let me talk about it for a second. Okay, so the question was, what does it mean to group by multiple columns? And the short answer is that for every row in the original table, you create a tuple of the values that are in all of the columns that you write down to group by. And then each group corresponds to a unique tuple. So if you group by two columns A and B, you look for all unique pairs of values in those, and each one of those will give you a group. By giving a group means that that will be a row in the result table. And any aggregation you do will be over only the rows that are the same in both of those columns.
I see.
So if I join together dogs and parents, where name equals child, now I have the parent and the fur. Oh, no, I don't. I have the parent and the fur. This is the child, and that's the child, and that's the child. Okay. And there are that combination, that combination, that combination. This we've seen before. This is new, and this is new. So out of 1, 2, 3, 4, 5, 6, 7 rows, there should be 6 groups. If we group by both the parent and the fur. So we end up with 6 rows. Now we didn't specify an aggregation. We probably should have. But if we just list out the parent and fur values, then we see all 6 possible combinations, but we got rid of the long Fillmore duplicate that only shows up once. If we wanted to see how many rows went into each of those, we'd see that there were 2 Fillmore longs, but everything else showed up just once. So yeah, so sometimes the specification for a group just appears across multiple columns, and that's why you use this. Yeah, as far as I can tell, it doesn't matter what order you put these in. And it's not the case that it groups by one and then the other. Like grouping by this would get you down to a smaller number of groups. You'd be down to 1, 2, 3, 4 different groups. So it never really groups by parent, and it never really groups by fur. It groups by the combination of these two, which gives you a larger number of groups, each of which has a fewer number of rows associated with it. Yeah, so how do you find the cousins? Can you do it with fewer than 4 joins? I think the answer is no. I think you need to join the parents table together 4 times to get the cousins, because you want to join 2 of them to get siblings. And then for each pair of siblings, you need to know who's the first sibling's child and who's the second sibling's child. So that's 2 more joins. Or, I mean, there's lots of ways to think about it because this is kind of symmetric tree structure. Another way to think about it is you start with cousin A, you find its parent, its grandparent, its uncle, and then its cousin. That's joining 4 different rows together in order to build it. I don't see another way. Yeah, so it's a good question. Like, what happens if you join together 3 tables? Because within the parents table, actually just once, there's all the information you need in order to find cousins. It's just that information is spread across multiple different rows.
I see.
If you join twice, parents with parents, then within one row, you have 2 kinds of relationships. You have child-grandparent relationships in a row, and you have sibling relationships within a row. These are in different rows, but they're all there if you've joined parents with parents. But anything that describes like an uncle or a cousin, that information is spread across multiple rows. It's all there, but you can't talk about it across a single row. You have to look at 2 rows at once. And whenever you have to look at 2 rows at once, you either are using aggregate functions, which don't really make sense here, like we're not trying to find the max or the sum of anything,
Mm-hmm.
or you need to do more joins in order to get the information that's currently on 2 rows onto one longer row. And then you can write whatever expression you want. So I guess there is one way to do it by joining, by only making 3 joins.
Mm-hmm.
And maybe I'll show you how to do that. And
Okay.
it might clarify things. So siblings looks like A dot child, B dot child.
Mm-hmm.
I know you know this, but it's just kind of like for the video. From parents as A, parents as B, where, and I specify that A dot parent is the same as B dot parent. So I'm only looking at rows with the same parent, and they have the 2 different childs. Those are all the siblings. That's true. You can get rid of the repetitions if you want by saying and A dot child is less than B dot child, and then that'll only be true in one direction.
I see. Okay.
The similar story for grandparents looks like A dot child, B dot parent.
Mm-hmm.
Where A dot parent equals B dot child. This has no repeats already because you're not like describing a sibling relationship which is symmetric in 2 different ways, and there's no like identities when it comes to grandparents. There's no dogs that are their own grandparents. So and that's just like a fact about the data. So that's all we would have to say about grandparents. The long way to write cousins would be A dot child, D dot child from parents as A, parents as B, parents as C, parents as D, where, and you kind of like write out this grandparent relationship twice. A dot parent equals B dot child and D dot parent equals C dot child. And then you want to make sure that the grandparents are the same. B dot parent equals C dot parent. And I think B and C describe the parent-grandparent relationships.
Oh, I see.
So this says same grandparent. And we went all the way up from A child through, so we went to B, over to C, and then back down to D, something like that. Now, this includes stuff that you wouldn't call a cousin, like Barack is not Barack's own cousin, so we got to filter all that stuff out. And how do you do that? Well, you have to write more conditions. And A dot child is less than B dot, D dot child, so we make sure they're different and they only show up once. And you have to make sure that B dot child, the parent, is different than C dot child, the other parent, because cousins aren't supposed to have the same parents. Okay, I think we found some cousins. There's the only way to really make this simpler is to create a grandparents table in advance.
Right.
Well, actually, you could join grandparents together twice, and but then you'll accidentally get siblings. Okay, this isn't so bad. If you have a grandparents table that has A dot child as kid, A dot parent as parent, and B dot parent as gramps, then we could select A dot kid, B dot kid. Well, maybe we should call them something besides A and B. So how about E and F? A dot E dot kid, F dot kid from the join of grandparents as E, grandparents as F. And here we want to say they're not the same and they have different parents. Uh-oh. Oh, and they have the same grandparent. That's important. Otherwise, you're not cousins. Okay, now we got the list of cousins. So, how many joins did it take to get us here? Well, we did this one join and then this one join. It's really just kind of getting rid of the duplicate work that exists here. When you join all four tables together, then you kind of have to express this twice. Whereas we here, in this case, just express it once and then reuse it here.
I see. Okay.
But I don't see any simpler way to do cousins than one of these two options.
This next question was about the logistics of the final exam.
Well, I bumped it up to 50 minutes, but not to make it longer, just to give you more time.
Okay.
And the way I'm thinking about it is that a normal final exam is 75 points
Okay.
worth of content.
Uh-huh.
I'm going to try to write this exam to be 50 points worth of content
Okay.
and then score it out of 100 by doubling everything's point value. So if you look in past exams, there's some like variability across how many points a problem is worth. Things that are kind of less complicated tend to be worth fewer points, and things that are more complicated tend to be worth more points. But if you take a 50-point subset of a past final exam, that's probably about the length of the total across all 3 days.
I see. Okay.
And will it be exactly right? I'll do my best, but because in the past, some finals have taken people longer than others, even though they're all 75 points. So it's not exactly perfect, the correspondence between time and points. But this will, in aggregate, across all 3 days, be a substantially shorter exam than what people have seen in the past. So I'm not going to at one point I thought I was going to take the topics that we've skipped and write more problems based on the topics that we haven't skipped. But I'm no longer planning to do that. Just the questions that I would normally write about topics that are not part of the course, I'll just drop out. But I'm not going to try to add more questions about other things. I'm just going to try to write 50 points worth and spread it across 3 days in a way that's that feels like about the same amount of time for each day. And then I'll have the TAs test it. But the TAs solve problems at different speeds than most students. So that process isn't always perfect. And we'll start with format I'll announce once we know. And I think we're pretty close. We have a candidate, but I don't want to tell you anything that is wrong. And but I will tell you now, it's not going to involve typing out lots of code like you did on midterm 2 if you took it. It's going to be more like really short answer, multiple choice kind of stuff that's easy to enter and won't cause people to have technical problems. Well, we don't really do scheme environment diagrams, so no. And for regular environment diagrams, instead of drawing one out, you'll just be answering multiple choice questions about